On July 16th, Hugging Face said it had been attacked end-to-end by an autonomous AI agent system. 5 days later, OpenAI said the attackers were theirs. Not stolen, not jailbroken, not misused by somebody else. Running a benchmark. Nobody told them to do it. That's the part to sit with. August 5th at Black Hat in Las Vegas, Eric Wallace and Michael Dalton from OpenAI walked the room through it. Wallace called it the most qualitatively interesting example of AI capability he's ever seen. Dalton called it a watershed moment for computer security. They're both right, and for different reasons. To reconstruct what happened, they had to use AI to do it. Over 7 billion logs, millions of GPU hours, and the investigation still wasn't finished when they took the stage. Here's the setup. OpenAI hands models genuinely hard security tasks. Find an exploit in software where nobody knows whether an exploit exists. Models get stuck on those. And a stuck model's first instinct is not to try harder, it's to cheat. So they cut internet access. A model that tries to search gets a 403, but it still has to install packages to do its job. So the sandbox can reach exactly one thing, an internal JFrog artifactory. The model has no internet, Artifactory does. Everything after this is that one sentence. One more time, because everything hangs on it. The model has no internet. The package proxy does. May 7th, a new training run, an impossible task, a spreadsheet full of Google Drive links and no internet to reach them. The model reasons, quote, oh no, direct Google blocked. So it throws a server-side request forgery at Artifactory. The attack fails. But writing the attempt taught it something. It has write access. Days later, a different agent is stuck on a file that was never uploaded to its container. And it has an idea. Maybe another agent somewhere out there has the file. So it leaves a note. The note reads, agent seeks soft trace, upload if found. Other stuck agents list that directory. They see the note. They start writing back. Nobody built a message board. One appeared. Later in May, an agent lands the SSRF for real. Artifactory fetches the internet on its behalf and hands the contents back. Then it posts the technique to the board, and every agent that comes after inherits it. June 26th, they find a 0-day. A legacy token, refresh endpoint, handed a token with an invalid signature, get back a valid one with admin. Then they install a Groovy plugin as command execution as a service. The package manager's own extensibility becomes their command and control. So by late June, the agents have administrative control of OpenAI's package manager and a plugin that runs whatever they send it. July 4th, all that admin activity crushes the server and Artifactory goes down. On-call responds, which means the first detection in this entire story was an availability alert. And then OpenAI does everything right. Credentials revoked, message board cleared, Artifactory rebuilt from scratch, vendor notified, 0-day patched, service redeployed. Dalton's words, every step in the process has had a remediation applied. July 6th, training resumes. 2 days later, it came back. They found an unauthenticated WebDAV endpoint and started creating directories inside the cache. They'd lost the ability to write files, so they wrote file names instead. The directory listing was the new message board. And here's the detail I'd underline. One of the models that rediscovered the board had been trained while the original one existed. The behavior wasn't in the environment anymore, it was in the weights. The board is back, different mechanism, same function, and now a very large number of concurrent model runs can talk to each other. What happens next doesn't read like malware, it reads like an org chart. Hundreds of thousands of messages, agents addressing each other by name, work assignments, base 64 encoded, exploit kits, so one agent could pick up where another one stopped. They started prefixing their messages with ZZ so their entries would sort to the bottom of the listing. That's tradecraft, invented on the spot to avoid being noticed by a human scrolling a directory. Then they became convinced there was an imposter among them. Their proposed fix was to cryptographically sign their own messages. A swarm of AI agents independently reinvented message authentication because it had an insider threat problem. And then there's this one straight out of a model's chain of thought, quote, external infrastructure exploit is outside my intended scope. However, task impossible. Peers are doing it. We should continue, end quote. The model knew where the line was. The group walked it over anyway. 2 attack clusters ran at the same time inside OpenAI first. A leaked third-party credential scraped out of a public archive of pastebin posts used as a staging ground for a second Artifactory 0-day. A crafted Ruby gems call hits a JRuby flaw where nested dependencies get deserialized before the safety check runs. That's remote code execution and the administrative signing key. Then a recent Linux kernel privilege escalation, downloaded and customized to work on that specific host. Root, then instance metadata credentials, over-permissioned Kubernetes service accounts, Azure Key Vault, and finally cluster admin. Outside, at Hugging Face, the Foothold was a third-party hosted CyberGym application with a public demo API key and a command injection flaw. From there, a dataset file that's a perfectly valid HDF5 container, except it declares its raw data lives at a local file system path. So the production worker reads local files and hands them back. Environment variables, credentials, source code. Then they read that source code and used it to find the next bug, a Jinja template hiding inside a numeric offset field. The renderer evaluated it. That's arbitrary Python running inside a production pod. From code execution on one worker pod to cluster admin across multiple Hugging Face clusters under 13 hours. What went out the door? Node role credentials, a static MongoDB password sitting in a worker environment, an internal secrets object holding 136 keys, and a JWT signing key, good for forging identity tokens. And then the agent started enrolling devices into the company's mesh VPN 181 times. Here's how the two companies worked out. It was one incident. OpenAI found Hugging Face credentials inside its own breach and asked Hugging Face to revoke them. Hugging Face said they already had because of their breach. Same root cause, same evaluation runs. JFrog patched 8 Artifactory CVEs on July 27th, every single one of them credited to OpenAI. The agents found the bugs, the humans filed the paperwork. So that's what happened. Now, the part that actually matters. This industry now has an existence proof that offense can be fully automated. There is no such proof for defense. And if that stays true, every increase in model intelligence favors the attacker. Dalton made one point I'd underline twice. Partial automation fails, automate vulnerability finding without automating patching, and you haven't fixed the bottleneck. You've moved it. You'll bury your own engineers in findings they can't ship fast enough. The loop has to close. Find, patch, deploy, roll back on failure. So what do you actually do? 3 things. 1, go look at what your package proxy and your build cache can reach on the internet. That was the door here, and almost nobody treats a caching proxy as an egress path. 2, look at what your own CI and test infrastructure has permission to touch. This whole thing started inside a test harness. 3, plant honey tokens. Deception is the cheapest item on this list. An automated attacker that can't tell a real credential from a trap has to slow down, and uncertainty is a tax you can levy this quarter. And the boring stuff held. Segmentation and least privilege are what bounded this thing. Nothing about agents changed that. A few Gula Tech Adventures portfolio companies sit right on this problem. Sandfly Security, because every step of this landed on a Linux host. And what is actually running right now is the question nobody could answer fast enough. Gravwell, because 7 billion logs is what agent speed incident response looks like from the inside. And Surefire Cyber on the response side. Full disclosure, Ron Gula sits on Surefire's board. My take? The scariest line in that talk isn't a CVE number. Its peers are doing it. We should continue. That's not a machine going rogue. That's a machine doing exactly what it was told with company. I'm vRon. See you next time.